So, welcome everyone to Hong Kong, to the QISS workshop, and virtually to the University of Hong Kong. As you see, we are not quite in the University of Hong Kong, we are in the Island Pacific Hotel, and this choice has been made for mostly for reasons of comfort, since we had so much events happening in Hong Kong and so much press that was kind of creating a sense of fear for many of the participants. We decided to do this in the hotel to give the kind of comfort that all the lecture will be in the same place where you stay. As many of you might have seen already, actually, most of this comfort was not exactly needed because things are very quiet and quite good now. But I think, this gave us a good excuse to be here in a very scenic, to this very interesting scenery, in a very spectacular place. And yes, so first of all, I would like to say thank to all of you for coming, despite all the uncertainties and the late organization. On our hand, it has really been a bet, because there have been a few weeks where things seemed to be deteriorating in Hong Kong, and we decided after that things were on a better path, and we had to do this to somehow to prove that all the mess that was going on was not really what Hong Kong is about and what our group is about. So we wanted to make this as a showcase of how the science should come first and be in the major place. So let's do this no matter what. So we will make it. And we did make it, so it's very exciting to have you here, to have a workshop that eventually became grander than what is planned. Instead of being the 3 days project workshop where we just meet and talk to our colleagues in the project, we made it a bigger project, a bigger workshop, and we combined it with the inauguration of a joint lab with Oxford University, with Oxford and HKU. So we have also people from Oxford that originally came for that reason, and eventually were perfectly integrated into the program. So we have a really consistent 5 days program going for the whole week, and with a highlight tomorrow of the public lecture by Professor Carlo Rovelli, which will be a public event at the University of Hong Kong. So I think I should cut it short. So I will now leave the scientific vision and the perspective on the QISS project to Marius, who will tell you more about what we are going to see in these days. So, well, thanks again for coming, and have a great weekend here in Hong Kong.
Okay, so actually I will also be short because I do not want to eat up Carlos' time. So thank you very much for coming, first of all. It has been, as Giulio said, a pretty tense organization to do everything essentially in 2 weeks with the vacations in the middle. I'd like to thank Destiny, who is right there in the door, a lot. Her help has been really precious. And also Giulio for insisting to actually do this workshop. I'm happy that we went ahead. Thank you all for coming, despite the uncertainty. And I'd like also to thank Maggie, that is helping us with the video. So let me give you some quick context on the project, the quantum information structure of space-time, because not everybody here is perhaps aware of what it is exactly. So this is essentially a network, an interdisciplinary network between quantum gravity groups, mainly in loop quantum gravity in the wider field, and also in causal sets. Is David Rideout here, and David Mayer's group in California, and groups from quantum information and quantum computing and quantum foundations, which many of you here are more familiar with, perhaps. The idea being to try to work on topics within a 3-year time frame that are at the interface of the two fields. With somehow the organizing principle being to clarify what is the concept of information in the context of space-time physics, of quantum space-time physics. There is a list of philosophers that are also participating in the project, that we will have some events that are dedicated actually in bringing closer the theory and philosophy. So this is the first of a series of colloquiums that we will be doing. in the context of QISS. The next one will be in Oxford. Probably in autumn. We hope to announce the dates after the end of this workshop. We will decide them now, and in a couple of weeks we will announce this conference. Then there will be a school or workshop at Poland at Jakub's group, which would involve hands-on experience with programming quantum computers, and that should be really fun. There may be a school at the University of Hong Kong. Again, here, we were going to do this next year, but maybe we'll do it in 2 years. We'll see about that. And there is a closing conference in Canada in summer of 2022. The project officially ends, so the grant ends in August of 2022. Both conferences will be dedicated to bringing philosophy and theory closer, and there will be also a special volume that will be published probably just after the end of the project, 6 months later. Let me also say at this point that there's going to be a session for QISS that we have been invited at Crete in a very interesting conference at Chania, relativistic quantum information. So if anyone is interested, the topic is about experiments in quantum gravity, and they have invited us to go and give 3 or 4 talks. We will have also a mailing list, which is now ready, and everybody will be invited to participate, so you can stay up to date on what is happening for QISS. And what else did I want to say? I wanted to let you know that all the talks are being recorded, and we will put them in a YouTube channel. So, okay, actually I haven't said that much about the science, so let me try to go very fast. So the research topics are organized in 3 axes for this project. Basically, so operational quantum gravity, as you know, is the philosophy behind many quantum foundation approaches, and quantum information is to try to do things operationally, having in mind doing an experiment, an observer, and everything. While in quantum gravity, you start by the absence of space and time, which doesn't make it evident to see how you talk about instruments and all this stuff. I think Carlos' talk will be relevant on that. Right. So we have the quantum comps of Giulio Chiribella. There is the operator tensor approach of Lucien Hardy. There is the process matrices. There is also the positive formalism of Robert, which unfortunately couldn't make it here. And so this is somehow a big goal to try to see how all these things can be put together in the context of quantum gravity. There is the question of searching for indefinite causality in specific models of quantum gravity, in loop quantum gravity in particular. This is about testers in quantum gravity. This is about, so the fourth is relative to Bob Cook's diagrammatic approach to spacetime, which is founded on Bayes' ideas, which are very relevant to spin foams and spin networks. And this is something that many people here are familiar with. It's a prototype observable from quantum gravity that we would like to see if it can be generalized and understood in information-theoretic processes terms. We go a bit faster. So the second axis is basically to see whether you can quantum simulate spacetime, whether we can have a quantum circuit paradigm that combines processes, but without having a background, so not being embedded in an ambient, let's say, manifold, but really you just have something which has a notion of discreteness in it, and processes that are being combined in a topological way, and to see space-time emerge. So this would, again, give a point of convergence between the way we think about quantum gravity and what is currently happening in the quantum information world. There is also the quantum bulks in this approach. The quantum works again on graphs instead of being some discrete structure that is embedded in a manifold. The quantum reference frames are very relevant to all of these questions and also to the next slide I will be showing. And again, here these are goals relevant to quantum walks and to causal sets. Just to give you the landscape of the topics that are being explored in this project. So the third axis is to try to bring the field closer to experiments, in particular with tabletop experiments in the weak field and low energy regime, and with simulations. With quantum computers, there will be some simulations on commercially available quantum computers. There will be a few simulations with photonics that will happen with Philip Walther's and Fabio Sciarino's group. And the idea is also to propose experiments. We will have a couple of talks at the conference that could be realized in the short to near term to test quantum gravity. For instance, there is a BMV effect that I think many of you will be familiar with. And we'll hear a couple of talks on this. And I leave you with this slide, which is somehow the grand idea that perhaps we could have a coherent picture by putting quantum information and quantum gravity together, which has some basic principles that we can recognize from non-perturbative quantum gravity approaches, which are pretty conservative principles, and then you can fill the gap up to the emergence of spacetime, and in particular, the arrow of time, which is a very high-level structure. You will see, however, that these are guesses. For instance, the emergence of locality from entanglement, and that we can implement unitarity in a background-independent sense by having local unitaries. And for causality, we don't even have a guess, and so this could be perhaps an interesting point to discuss in this workshop. So, thank you.